Hello student, today I'm going to discuss with you the topic on friction. So as you have all come across this in physics, so let me just state the definition. What is a definition of friction? It is a property by which virtue of which a resisting force is created between two rough bodies which check the sliding of one body over the other is called the friction. And this force which always in the direction in which the body has tendency to move is called the force of friction. So that is, if you have here two rough bodies, or suppose here you have two rough bodies which are in contact, that is this surface also, this rough surface, rough, and this body also, it is a rough body. So if they are in contact, these two bodies are in contact, then if this body has, if a force is applied such that this body has tendency to move in this direction, so there will be a force of friction, which there will be a force which opposes the motion of this rough body on this rough surface, and that force which opposes the direction of the body in this direction, that force is in this, the force which opposes this motion of a rough body is called the force of friction. So as you can see here, by definition, the property by virtue of which a resisting force is created between two rough bodies which check the sliding of one body over the other is called friction, and this force is always in the direction in which the body has tendency to move is called the force of friction. So as in this case you have seen here, okay, let me just go down, draw it nicely below. Let me draw here what is meant by friction. Friction, it is by property, it is the virtue in which the body has tendency, it is the force in which, if you are having two rough bodies, okay, this is a rough body, we will call it as a rough body which is in contact with a rough surface, okay, this rough body is in contact with a rough surface, this is a rough surface, okay. So by, let me go back, the property by which a resisting force is created between two rough bodies which check the sliding of one body over the other is called the friction. And this force which always is there in the direction in which the body has tendency to move is called the force of friction. So here, so the property by virtue in which two rough bodies are in contact, in which the resisting force between which is applying on this two rough body, that is, which resists the motion of this body. Suppose here this body has a tendency to move in this direction, the direction in which this rough body has tendency to move, then there is a resisting force which opposes this motion of this rough body, and that resisting it is due to friction. And this friction occurs in case both the surface are rough or one surface, at least one surface is rough. And this friction, which always opposes the motion, that is friction, force of friction, which is in this direction, always oppose the direction of the motion of the body, or in which the body has tendency to slide. So if it is an inclined plane rough surface, this one, if this is a rough body, okay, which is in contact with a rough surface, in this case, if the body has a tendency to move downwards, then the force of friction which always opposes it will be in this direction, that is F. Here we denote the force of friction to be F, and then this force of friction always opposes the motion of the rough body and the rough surface. So but in case if both the surface are smooth, okay, this is a smooth body and this is a smooth surface, then there will be no resisting force acting here between these two bodies which are in contact. Why? Because the force of friction will be absent. But if at least one of the surface is rough, then the force of friction always applied, and the force of friction always acts in the direction in opposite, always oppose the direction in which the body has tendency to move. So I hope it is clear to you what is meant by force of friction. It is the force in which always opposes the direction of their body in which it has a tendency to move. And what are the laws of statistical friction? The laws of statistical friction here, it states like this. When a body rests in contact with a rough surface and is acted by a force urging it to slide on the surface, the force of friction always satisfies the following laws. And what is that? The direction of the force of friction is always opposite to that in which the body has tendency to slide. So when a body which is in contact with a rough surface, then and it is acted by a force urging it to slide on their surface, so there is a applied force which is applied on their body, so such that the body will start moving. Then in that case, the force of friction or the direction of the force of friction, which always oppose the motion of the body, will act in the opposite direction. And the magnitude of the force of friction is such that it will be sufficient to prevent the sliding motion of the point of contact subject to the maximum limit. So what is meant by this first law here? The direction of the force. So if you have this, suppose this is a rough surface and this is a body which is in contact with a rough surface. So if there is an applied force, if there is a force which is acting on this body, which is applied on this body such that body will have a tendency to move in this direction. So the force of friction which always oppose this, the direction of the force of friction will always opposite to the direction of the force of, always opposite to the direction in which the body has tendency to move. Or suppose it is on a flat surface also, which is a rough surface, and this body is which is in contact with this rough surface, and if there is a force which urge this body to move, suppose here there we applied a force on this rough body, on this body, which urge it to slide in this direction, then the direction of the force of friction which always oppose the motion of the body will be in the opposite direction. So this is the force of friction, that is the direction of the force of friction, because the body has a tendency to move or to slide in this direction. And the magnitude of the force of friction is such, and the magnitude, that is the maximum force or the length of the magnitude of the force of friction is such that it is sufficient to prevent the body from sliding. So the maximum of the force applied here, that is the force of friction applied on this body, acting on this body which is in contact with rough surface, is just sufficient to prevent this body from sliding. And it is subjected to certain maximum limits. So if you apply a force, if there is a force here applied on this rough body which moves it in this direction, so the force of friction applied acting here will be sufficient to prevent the body from sliding. And the magnitude of the friction always bears a constant ratio to the normal reaction. So here the third law is that the magnitude of the force of limiting friction always bears a constant ratio to the normal reaction between the two bodies of contact, and the ratio depends only on the nature of the roughness of the material of which the body are composed, but not on the shape or extent of the surface. By limiting friction here, we mean the maximum force of friction applied which is sufficient to prevent the body from sliding. So the magnitude of that force of limiting friction always bears a constant ratio to the normal reaction and between the two bodies of contact, and that ratio depends only on the nature of roughness, so on the nature of roughness of the materials, but not on the shape or the size or the extent of their body. So by limiting friction and limiting equilibrium here, when a body we define it as when a body in contact with a rough surface is acted by a force, and it is in a condition that it is about to slide on the surface, the force of friction at the point of contact having reached the maximum limit, the body is said to be in limiting, and at that point the body is said to be in limiting equilibrium, and the force of friction at the point of contact is called limiting friction. So in this case, how we define this limiting equilibrium and limiting friction is that, suppose here this is a body, okay, when a body which is in contact with a rough surface, this is a rough surface, and this is a body which is in contact with a rough surface, and this body is in a condition that it is about to slide. It is about to slide or to move in this direction. Suppose it is about to move in this direction, then the force of friction at this point of contact, the force of friction at the point of at this point of contact, having reached the maximum limit, because the having reached the maximum limit means at that time where the body is about to slide, the force of friction having reached the maximum limit such that it will oppose this sliding, such that it will oppose this motion of this body from sliding, having reached the maximum limit, then this body at that point is said to be in limiting equilibrium, and the force of friction that at that time, that is the when it have reached the maximum limit to oppose the sliding of this body, is said to be the force of, is called the limiting friction. So as you can see here in the definition, when a body in contact with a rough surface is acted by a force, and it is in a condition that this body is about to slide in this direction, then the force of friction having reached a maximum limit, that is which post the sliding or the motion of this body having reached the maximum limit, then is called the force or the limiting friction, and the body at that time is called the body which is in contact with this rough surface at that time where the limiting friction is maximum is called in limiting equilibrium. So what is the coefficient of friction? It is the constant ratio of the limiting friction to the normal reaction. So if F here is the force of friction, that is the max having reached the maximum limit to prevent the body from sliding, and R is the normal reaction, then we have the constant ratio here, that is mu here, is equal to F by R, and this F is called the coefficient of friction, and it is, or we can say that F is equal to mu R. So what is coefficient of friction? It is the constant ratio between the limiting friction, that is this F here having reached the maximum limit to prevent the body from sliding down, and R is the normal reaction at the point of contact. Then the ratio between these two is called the coefficient of friction, and from here it implies that F is equal to mu R. And what is the angle of friction? In case of limiting equilibrium, means when the body is having reached body is said to be in limiting equilibrium when the maximum limit of friction is applied such that it prevents the body from sliding down or moving away from that position of contact. Then the angle made by the resultant. So if you have R here is the normal. If I draw here in a rough surface, this is a rough surface, and this body is here, okay, which is in contact with a rough surface. This is a rough surface. So as you can see here, this surface, this body has a tendency to move downwards. So in that case, the force of friction which always opposes it will be in this direction. So F here is equal to mu R having reached the maximum limit, and R is the normal reaction perpendicular to this. R is the normal reaction perpendicular to this body on this rough surface. So the angle between these two should be 90 degrees. The angle between R and F. This is F. So what is the angle of friction defined here? It is the angle, and by the resultant of forces, if you have two forces, okay, then one is this F1 and this is F2, then we denote R to be the resultant of this acting at this point. So similarly here also, then we denote S to be the resultant of these two forces, that is R and F is equal to mu r. So the angle made between this resultant of these two forces, that is the angle between this S, which is the resultant of F and R. So the angle between the resultant of this force F and R with the normal reaction, R is the normal reaction here, is called the angle of friction. I hope it is clear. So suppose here you have AC, here is this, the direction AC is the direction of this force of friction, and AB is the direction of the normal reaction, and AD is the direction of the resultant of these two forces R and mu R, and we denote the resultant as the resultant of these two forces F R. R here is the resultant, is the normal reaction which is in this direction, and mu R is in the direction of AC, and S is the normal reaction, the resultant of these two forces R and mu R. So the angle made by this resultant S with the normal reaction. So in this case, the angle made by this resultant S with this normal reaction R is called the coefficient of friction and is denoted by lambda. So if lambda is the angle between the resultant of the force Fr, F is equal to mu R and R, that is the angle, and then tan theta, then tan lambda will be equal to F by R. And what is F by R? As we have seen, it is equal to mu, the coefficient of friction. So thus we have here, tan lambda is equal to mu. So therefore, lambda here is, that is the angle made by the resultant of these two forces F and mu R with the normal reaction is called the angle of friction. I hope it is clear to you.